We go. Tom, we will have to meet your dog at some point during the talk. So welcome YouTube. I'm going to presume that YouTube is streaming. Welcome to the next Water, Wetlands and Watersheds seminar of spring 2026. Once I get the thumbs up in the chat that I know that we're streaming, we will go ahead. Just pause for a second. YouTube stream is good. Okay, excellent. So welcome everyone. We're seeing this, we're seeing this. Okay, welcome to the Water, Wetlands and Watersheds. It's our kickoff seminar of the semester. And we are very lucky today to have with us Tom Biebighauser. Am I saying that right, Tom?
Yes, you're doing great. Thanks.
All right, perfect. So Tom Biebighauser has restored more than 3,600 wetlands and streams across Canada, the US, Mexico, New Zealand, Puerto Rico, and Taiwan during the last 47 years, right? And congratulations on your 48th birthday. So yeah, you've been doing it for a long time. He's developed a very effective and low cost and repeatable and long lasting method for building wetlands and streams. Tom retired from the US Forest Service in 2013 after working there for 34 years. And since then, he's been working to restore at least 100 wetlands a year, wetlands and streams per year. He estimates that he's built more than 1,400 dams and has since decommissioned over 300 dams to restore natural hydrology and function. So things sort of like working in one direction and then in retirement, maybe trying to work back the other way. He's teaching a graduate level course in wetland design at the University of Louisville, the School of Engineering there. And also teaches classes at University of Alberta and the British Columbia Institute of Technology. He's the author of 4 books, including this one here, Wetland Drainage Restoration and Repair, which I'm lucky enough to have a signed copy of. And he has a series of videos that you can watch online for free, which I'll put the link in onto the syllabus and everything like that. Okay, so I've admitted everyone into the room. What I'm gonna do now is play a video. It's about a 30-minute video. Tom will be here with us. I'm going to turn off video and everything, but we'll watch the video here. It should be streaming to YouTube and Zoom. Then we'll come back and we'll have the opportunity for some discussion. So this is where I am sharing the video. So that goes right. That looks right here. And I go to the actual video. All right, and I'm about to press play. So if you're on Zoom and it's not working, send me a chat. Otherwise, here we go. We're gonna pause the video real quick and reshare the Zoom, making sure that everything is optimized and working. So we're gonna share sound, optimized for video. There's the media player. Gonna share it again. We will try one more time. And we'll just thank you for people in the room for a little bit of patience. Now, one more time.
Hi, I'm Tom Biebighauser with Wetland Restoration and Training. I'd like to show you how it's possible to build a wetland that will last forever. How do I know this is possible? I've studied natural wetlands that are over 10,000 years old and constructed wetlands that were built over 2,000 years ago. Well, I'm anxious to show you the techniques that you can use to build a wetland that won't require maintenance. Let's get started. We call this wetland Booth Pond. It's a natural wetland that's over 10,000 years old. Booth Pond is located on a mountain ridgetop on the Danube National Forest in Kentucky. Booth Pond is a small and shallow basin that's lined with clay that's compacted. The trees you see in Booth Pond are growing on mounds in a natural basin. Booth Pond has a very small watershed. There are no streams or drainages entering Booth Pond. Booth Pond does not have a dam or a water control structure that would require maintenance. The spillway or overflow for Booth Pond is wide and carries water in a sheet-like pattern that does not cause erosion. This is Cliff Palace Pond, a natural wetland in Jackson County, Kentucky on the Danube National Forest. Carbon-14 dating shows that Cliff Palace Pond is over 10,000 years old. Cliff Palace Pond is located on a mountain ridgetop surrounded by sandstone cliffs. Cliff Palace Pond is in a shallow basin. The bottom of the basin is clay that's compacted. The firm basin shows that Cliff Palace Pond dries long enough for bacteria to decompose the leaves and branches that fall into the water. Cliff Palace Pond will dry in a drought. Cliff Palace Pond has a very small watershed. There are no streams that enter Cliff Palace Pond that could fill it with soil. Cliff Palace Pond is a natural basin that is 3 feet deep in the middle. Cliff Palace Pond does not have a dam or a water control structure. This wetland was built by humans over 2,000 years ago. The wetland and many others like it were built by shaping and compacting clay to form basins on a ridge that's high above the Little Miami River in Ohio. There are 114 wetlands that were dug by hand over 2,000 years ago at the Fort Ancient Earthworks and Nature Preserve near Oregonia, Ohio. The wetlands at Fort Ancient were dug by hand using mussel shells and sticks. The soil that was removed was carried by hand in baskets to build 3.5-mile-long earthworks that encircles the outer edge of the ridge above the Little Miami River. The constructed earthworks is not a dam. Most of the constructed wetlands at Fort Ancient contain water in the winter and spring and dry in the summer and fall. We call these wetlands that dry from time to time vernal ponds or ephemeral wetlands. The wetlands at Fort Ancient are from 1 to 3 feet deep. They're deepest in the center with gradual slopes around the edges. Trees and shrubs are not growing in the wetlands. This shows that they hold water long enough so that trees and shrubs can't grow. The wetland basins at Fort Ancient contain clay that was purposely compacted. Some of the vernal ponds are lined with gravel. The gravel was carried by hand in baskets uphill from the Little Miami River. The vernal ponds are being used for breeding by fingernail clams, frogs, toads, salamanders, and dragonflies. One reason the constructed vernal ponds have survived this long is that they dry annually. This creates conditions where the leaves and branches that fall in the water will decompose and not fill the basins with soil. Each wetland is surrounded by a very small watershed some call a catchment. There are no ephemeral, intermittent, or perennial streams or ditches like this one that flow into the wetlands that would have filled them with soil. The wetlands are based on compacted clay, so water is slow to soak into the ground. Tree roots growing under the vernal ponds cannot remove water from the ponds because of the compacted clay layer. The overflow or spillway for the wetlands at Fort Ancient Earthworks are wide. This allows water to leave the wetlands in a sheet-like pattern and not cause erosion. The wetlands are located on high ground, not on the floodplain of a river or a stream where they could fill with soil during a flood. The wetlands have not been drained or filled with soil like what is done to create farmland. The wetlands were not built with dams like this one that can fail. The wetlands were not built with water control structures that will leak and fail to hold water. Let's look at how you can build a wetland like this one that was restored on a mountain ridge in Kentucky 14 years ago. Most natural wetlands are found in shallow basins with natural high ground or a rim bordering the downhill edge. The natural rim is generally wider than 20 meters and has gradual slopes no steeper than 5%. The natural rim acts like a dam, but does not look like a dam because of the low elevation and gradual slopes. Wetlands are drained by digging a ditch through the rim of a natural wetland. The soil contained in the rim is then used to fill the wetland basin. This LiDAR image shows the basins of drained wetlands and the ditches that were dug to drain the wetlands. Restoring a wetland involves reshaping a basin that will hold water and filling ditches that were cut through the rim of the natural wetland. This large basin is for a wetland measuring 1 hectare in size. The wetland basins you build can be large or small. You can build a wetland basin to be shallow like this one, or deep like this one. The wetland basin can be shaped to be smooth or varied with pits and mounds so shrubs and trees may grow in the wetland. Start the design process by identifying an area where there is no stream, no ditch, or drainage that would enter the wetland. This is a good place to build a wetland that will last forever because the area does not flood and there are no streams or ditches entering or leaving the area. Walk around the area to identify and map ditches. Examine ditch banks carefully to see if you can find the outlets of buried drainage structures. Look for pieces of pipe that indicate drainage structures were buried on the site. Look carefully for vertical holes that often indicate the presence of buried drainage structures. Set up a long-range laser level with a red beam on a tripod next to the area where you want to build the wetland. Use a laser receiver and a dual-sided grade rod to measure the change in elevation from the upper to the lower edge of the wetland you would like to build. Record the elevations you take with a dual-sided grade rod on a GPS and on a wetland design form. Use plastic flagging to mark the perimeter of the area where you would like to build the wetland. The area you mark should have no more than a 2-foot or a 61 centimeter change in elevation from upper to lower edge. Lay out a wetland with a natural shape like this one we built at Ball State University in Indiana. Don't mark a rectangle or square with straight lines that look artificial like this pond that someone else built. Use an open-face clay auger to dig a deep test hole near the center of the wetland you would like to build. Wait and see if groundwater enters the hole. You may be able to use the groundwater technique to build the wetland if water seeps into the hole and rises near the surface. Use the ribbon test to measure clay content in the soil. You may be able to build the wetland using the surface water technique if you can form a long and thin ribbon that does not break that is at least 2 inches or 5 centimeters long. This open-face clay auger contains soil that is very high in clay. One would need to use an aquatic-safe liner to build a wetland on this site. This is because the short sections of ribbon show that the soil is low in clay. Also, groundwater did not enter the test hole. An aquatic-safe liner is needed to build a wetland on this site because groundwater did not enter the test hole and the soil texture is low in clay. I strongly recommend using an excavator to dig deep test holes when designing a wetland project. One can better see and measure the depth and the thickness of soil layers that are exposed in the deep test holes dug with an excavator. This deep test hole shows that groundwater is near the surface and a wetland may be built using the groundwater technique. The reason groundwater is not at the surface is that ditches and buried drainage structures were installed to drain the historic wetland so it could be farmed. This table can help you choose the best technique for building a wetland on a site. Each technique is based on soil texture by layer and the elevation of groundwater that's found in the test holes you dig. This key can help you choose the best technique to use for building a wetland on a site. Here's a wetland that was built using the surface water technique with a groundwater dam. The surface water technique with a groundwater dam is used where there is a thick layer of clay over a thinner layer of gravel that overlays impermeable bedrock or a very thick layer of clay. When building a wetland using the surface water technique with the groundwater dam, it is of critical importance that buried drainage structures are removed and subsurface permeable layers of soil are interrupted by digging a core trench around the lower 2/3 perimeter of the wetland you're building, and then filling this core trench with clay in thin layers that are compacted to form a groundwater dam. I developed the surface water technique with a groundwater dam because it is the most effective and the lowest cost way to build a wetland of any size. Groundwater dams are effective because they block buried drainage structures that are made from wood, rock, clay tile, or plastic. They reduce water losses from roots, root channels, and topsoil. They block water leaving the wetland underground in permeable layers of organics, gravel, sand, silt loam, and loose clay. And they allow burrowing crayfish to live in your wetland without draining the wetland. A groundwater dam is built along the lower 2/3 perimeter of the wetland you've designed. The top of the groundwater dam should be equal to or higher than the elevation of water or saturated soil in the wetland that you're building. To restore a wetland, it is necessary to fill the ditches and to restore the natural rim along the lower side of the wetland that was drained. The groundwater dam will block the flow of water in buried drainage structures and in the ditches that have been filled. A groundwater dam should be used wherever you are blocking a ditch to build a wetland. The groundwater dam will block the water you see flowing in the ditch and the water you can't see that's flowing underground in the ditch. Here's where a groundwater dam should be built when you are building a wetland that is near a ditch that cannot be blocked by the project. The groundwater dam will prevent the ditch and the water flowing in underground drainage structures from drying the wetland that you're building. Here's how we use an excavator to build a groundwater dam to block a ditch as part of a wetland restoration project. The excavator begins by digging a trench across and perpendicular to the ditch. The ditch is shown by the red arrow. The soil that is organic or low in clay is placed along the downhill or downstream side of the trench being dug. This soil will not be placed back in the trench. The soil that is high in clay is placed along the uphill side of the trench. This clay will be placed back in the trench to form the groundwater dam. The excavator operator digs down into a very thick layer of clay that is gray in color. The clay soil that was saved is mixed and placed back into the section of trench that was dug. The operator compacts the clay soil in layers using the bucket on the excavator. To gain maximum compaction, the operator tips the excavator forward so the entire weight of the machine is on the bucket. The core trench is dug and filled in sections to build the groundwater dam. The additional soil needed to fill the core trench is obtained from within the wetland basin being restored. The groundwater dam will help block the flow of water both in the surface and underground in the ditch. We built this wetland using the surface water technique with a groundwater dam over 36 years ago. We built this forested wetland 25 years ago using the surface water technique and a groundwater dam. Here's a wetland we built 30 years ago using the surface water technique with a groundwater dam. We built this wetland at Sweetbriar College in Virginia using the compacted clay liner technique. The compacted clay liner technique is used where it's not possible to build a groundwater dam and there's a layer of clay near the surface that is at least 4 feet thick. The compacted clay liner technique is difficult and costly to use. This is because it is necessary to spread and compact in layers clay so that it is at least 24 inches thick in the basin to form a wetland. Here's a retired sister at St. Anne's Convent in Melbourne, Kentucky, helping us mark the perimeter of a wetland to restore in an old field. The soil test holes we dug showed that there was a 3 to 4 foot layer of clay near the surface with dry sand beneath. We began construction of the wetlands by using an excavator to remove the vegetation and the topsoil. The vegetation and topsoil were placed in a pile for later spreading in and around the completed wetland. The next step involved removing and piling all the clay within the planned wetland area. We were careful to pile the clay on bare ground so it would not become mixed with vegetation and topsoil. We now used the excavator to remove sand that was beneath the clay. We removed a layer of sand that was from 24 to 48 inches thick. We dug out enough sand so that 24 inches of clay could be placed over the sand in the basin without filling the basin. We set up the laser level on a mound so the beam would be above the tall vegetation in the field. We first used the laser to measure how much sand to remove and then to monitor the thickness of compacted clay we used to line each basin. Here the excavator is being used to spread a 6-inch thick layer of clay over the sand in the basin for the wetland. The excavator then travels over the layer of clay to compact it. The next step involves traveling over the layer of clay with a tractor that has rubber tires. To obtain greater compaction, the tractor operator carries a full bucket of soil as it drives over the clay. The tractor operator travels around the wetland basin in different directions to compact the clay. The excavator spreads the second layer of clay over the first layer of compacted clay. The tractor travels over each layer of clay multiple times until it's compacted. We frequently measure the degree of compaction with a penetrometer and the thickness of compacted clay using a laser level. We keep adding and compacting layers of clay until there is at least 24 inches of compacted clay over the entire wetland basin. The topsoil that was saved is now spread over and around the compacted clay in the wetland basin. The excavator is used to plant clumps of vegetation that were saved when the area was cleared. Wheat and native plants are seeded in and around the finished wetlands. Here's how one of the wetlands we built at St. Anne's Convent using the compacted clay liner technique appeared 3 years after construction. Here's one of the wetlands we restored using the compacted clay liner technique near the community of Sparwood in British Columbia. This small vernal pond was inadvertently created using the compacted clay liner technique when iron ore was mined in Bath County, Kentucky almost 100 years ago. We built this wetland using the groundwater technique near Meadow Creek in British Columbia, Canada. If groundwater fills the test hole you dig, then you may be able to build a wetland on the site using the groundwater technique. Here's how a vernal pond wetland we built looks in the spring on a site where groundwater is near the surface in the spring. And here's how the same vernal pond looks when the groundwater drops to more than 6 feet below the surface in the fall. Here an excavator is being used to build a wetland using the groundwater technique. Groundwater is rapidly filling the depressions being made by the machine. The excavator operator keeps the machine from sinking by placing logs under the tracks. Logs are placed in the wetland to provide purchase for birds and turtles with basking sites. Here the excavator is digging a core trench for building a groundwater dam. The core trench is being dug perpendicular to the flow of water in the ditch. The ditch is shown by the red dashed arrow. Here are some of the pipes unearthed when digging the core trench for the groundwater dam. The disadvantage in using the groundwater technique is that there's a lot of soil that needs to be spread. Think of how much space it would take if you flipped a pie out of a pie pan. The same is true when digging a wetland using the groundwater technique. Here's one of the wetlands we built using the groundwater technique the day it was finished. The site looks unattractive with all the exposed mud. This photo shows another wetland we built using the groundwater technique. The new wetland doesn't look good because the water is muddy. The photo was taken the same day the wetland was built. The new wetland looks great 1 year after construction. The logs are being used by the western painted turtle for basking. The soil we removed and spread has become wet meadow wetland. While building the wetlands, I could hear water running near the wooden bridge that people were standing on. The sound was made by water flowing over the head cut under the bridge. We had to control the head cut before it could advance and destroy the wetlands we were building. The excavator began by digging a deep trench across the floodplain of the ditch immediately upstream and adjacent to the head cut. We dug the ditch deeper than the bottom of the ditch downstream of the head cut. We used a tape to measure the length of the trench that spanned the floodplain of the ditch so we could find and cut trees that would fill the trench. We used the excavator to place the largest diameter trees we could find in the trench. We worked to fit the trees tightly together in the trench. The excavator operator used the bucket on the machine to push the logs into the ground and to pack them tightly together. Soil was pushed into the gaps between the logs and to cover the logs, forming a wide floodplain with low banks and a narrow channel in the middle for water to flow over the logs into the deeper channel downstream of where the head cut was located. The floodplain was shaped so that water would flow over the logs in a sheet-like pattern and not cause erosion. Clumps of sedges were embedded into the soil over the logs to control erosion. I've been using aquatic safe liners to build wetlands like this one, and this is where clay soils are not present and groundwater is not near the surface. We've been building wetlands for rare species of amphibians and reptiles across North America using aquatic safe liners. This drawing shows a profile view of how a wetland may be built using a one-piece factory-seamed aquatic safe liner that is protected on both sides by thick layers of geotextile and covered with at least 6 inches of soil. The most efficient way to build a wetland using an aquatic safe liner is to use an excavator. Here the excavator removes trees and shrubs from a location where a wetland is being built. You can see a piece of rebar that we used as a stake to mark the center of the planned wetland. The excavator digs a deep hole in the center of the area where the wetland is being built. The elevation in the bottom of the hole is equal to the final depth of the planned wetland, plus the thickness of soil to be placed over the liner in geotextile. The stake serves as a guide when digging the basin for the wetland. The wetland basin is dug deepest in the center with slopes no steeper than 20%. The gradual inside slope prevents soil that is placed over the liner from slipping downhill if deer or elk wade into the water. Digging the wetland basin is much like removing pieces of pie from a pie pan. It is of critical importance to be on site working with the heavy equipment operator to build a wetland using a liner. Here the end of the tape has been placed over the rebar stake. The tape is stretched out to a distance equal to the radius of the liner being used. A laser level is used to check the elevation of the ground at a distance equal to the radius of the liner being used. All the elevations around the perimeter of the basin must be the same. Any low spots would reduce the depth of water in the finished wetland. Elevations are checked before the excavator moves to dig another section of the basin. Once the basin is dug, all rocks are removed by hand before the liner and geotextile are placed. Removing the rocks from the basin takes time, but helps to ensure that the wetland will hold water as planned. A pickup truck is used to transport the liners and geotextile from where they are stored to the worksite. A thick layer of fabric called geotextile is placed in the basin to protect the underside of the liner being installed. A fish-grade, aquatic-safe liner is placed over the geotextile. Another layer of geotextile is placed over the liner to protect the surface of the liner. 12-inch long landscape spikes are used to anchor the top edge of the liner in geotextile. These are placed 1.5 feet apart. The 12-inch long spikes are used to anchor all 3 layers, preventing the materials from slipping when being covered with soil. The corners of the material are cut and removed before covering with soil. Wire flags are placed along the perimeter of the geotextile and the liner to show the excavator operator where the liner is located while covering with soil. Here is the aquatic safe liner that's sandwiched between layers of geotextile and it's ready to be covered with soil. The basin is shaped like a large satellite dish. The excavator is used to place from 6 to 8 inches of soil over the liner and geotextile. Absolutely no heavy equipment is allowed to travel over the liner. The liner will tear and the basin will fail to hold water if any part of heavy equipment drives over the liner and geotextile. At least 6 inches of soil is placed over the liner, including the top edge of the liner. The pink flags show the excavator operator where the edge of the liner is located. Here's how the wetland appears after the liner has been covered with soil and large woody debris has been placed. This wetland was built 5 years ago in California using an aquatic safe liner. The wetland is being used by the federally threatened California red-legged frog. This wetland was built 4 years ago on BLM land in California using an aquatic safe liner. It's also being used by the California red-legged frog. Here's a wetland we built 10 years ago with an aquatic safe liner at the Falmouth High School on Cape Cod, Massachusetts. Wetlands may be built any size using aquatic safe liner. Here we're building a wetland that's 1.5 acres in size and 10 feet deep using aquatic safe liner. The liner and geotextile are placed in the basin in strips that are 24 feet wide. A professional crew seams each strip of geotextile and liner material. A large excavator and wheel loader are used to cover each strip of liner and geotextile before the next sheet is seamed. No heavy equipment or wheeled vehicles are allowed to travel over any part of the liner in geotextile. Here's how the large wetland appears 4 years after construction. This is the stream we built that supplies water from a well into the large wetland. The stream was also built using aquatic-safe liner. Avoid building a dam if you're serious about building a wetland that will last forever. All dams require frequent and expensive maintenance or they will fail to hold water as planned. Even low and wide dams like this one require frequent maintenance. I've built over 1,400 dams in the past 47 years, and I have yet to figure out how to build a dam that does not require maintenance. Building a dam is a traditional practice, one that must end if you want a wetland to last for thousands of years. Muskrats are the main cause of dam failure in North America. Muskrats will burrow into the dam and cause the dam to fail. The entrance to a muskrat burrow is below the surface of the water. Muskrats build a living chamber in the portion of the dam that is above the water level in the wetland. Over time, muskrats will burrow through the dam. This can cause the dam to wash out in only a few hours. This muskrat burrow goes through the dam. We had to drain this wetland with a pump so the muskrat burrows in the constructed dam could be repaired. One must use heavy equipment to dig out and expose the muskrat burrow and then fill the trench with soil that is high in clay and compacted. The wetland should be drained prior to repairing muskrat burrows. This photo shows a muskrat burrow that goes through the dam. Muskrats will quickly destroy a dam that has water on both sides. Here's where a coyote dug out the muskrats that were living in a dam. The large holes drain the wetland. Here is where beaver have blocked the spillway constructed to prevent water from flowing over a dam. This can cause the dam to wash out. Beaver blocking spillways with their dams have caused many dams to erode and wash away. Beaver have dug a channel through this dam. The beaver channel is draining the wetland like a ditch. Here's another canal beaver dug through the top of the dam of a constructed wetland. You're looking inside of a flashboard riser water control structure that beaver have blocked. This can cause water to flow over and wash out the dam. The red arrow points to the top of a flashboard riser water control structure that has been covered by beaver. The water control structure is still leaking because water is flowing through the gaps that are between the boards in the water control structure that's below the surface, and this is draining a very large wetland. The island you see is where beaver have buried a water control structure in a constructed wetland. It would be very difficult and costly to repair the structure. Livestock have damaged this dam and the spillway for the dam. This dam is also being damaged by livestock. This wetland was built by constructing a dam across an ephemeral stream. The wetland is failing because the spillway is too narrow and carries water down a steep slope. Two major head cuts developed in the spillway, and these are carving a deep canyon that will cause the dam to fail. The dam will soon wash away and the wetland will go dry. You're looking at Drew Lake, a natural wetland on the Umpqua National Forest in Oregon. Drew Lake was about to be destroyed by head cuts that were located in a small stream flowing out of Drew Lake. The location of the head cut and the stream are shown by the red arrow. The red arrow points to the head cut. The head cut is advancing into the wetland and would soon destroy the wetland. We controlled the head cut by installing a buried vertical grade control structure that was made from rock across the 100-year floodplain of the stream. Avoid using pipes in wetland construction. This leaking drain pipe was discovered when rebuilding a failed wetland. No one was aware of the presence of the pipe. This leaking pipe is draining an impoundment that was constructed 50 years ago. Avoid using water control structures in wetland construction. All water control structures will eventually fail, draining the wetlands that are built with them. Ice has damaged this water control structure. The dam is also riddled with muskrat burrows and beaver canals. Avoid using valves and boxes when building wetlands. These will eventually fail. This rotted walkway leads to a water control structure valve that is rusted and needs to be replaced. The open valve can no longer be closed because the valve is rusted. The open water control structure is draining a huge wetland near Golden in British Columbia. I have installed over 1,000 plastic and fiberglass water control structures in wetlands. All will eventually leak and require maintenance. The plates in modern water control structures contain rubber gaskets. These gaskets will compress and tear, causing leaks that drain wetlands. The gaskets must be replaced every few years. This person is trying to close a leaking valve in a water control structure that's draining a constructed wetland. An outdated way of building wetlands is to surround a field with a poorly made dam and then install a pump to fill the impoundment with water. Wetland managers have found that this technique does not work. Pumps require frequent and expensive maintenance, and the cost of purchasing electricity to operate pumps is very high. Wetland managers will tell you about the serious and expensive problems that are associated with using pumps and wells to fill wetlands. A tremendous amount of money and time are wasted pumping water into constructed impoundments that leak worse than a bucket with holes in it. When working with engineers, require that all wetland projects be designed and built without using dams, berms, levees, dikes, diversions, ditches, wells, pumps, or water control structures. I have found that people will rarely, if ever, maintain a dam or a spillway or water control structure after I build the wetland. This is why it's critical you don't build weaknesses into wetlands that will require maintenance. It is possible to build a wetland that looks and functions like a natural wetland. It is possible for us humans to build wetlands that will last for thousands of years. If you look, you can find examples of human-made wetlands that are many years old. Insist on using techniques to build wetlands that will not require maintenance. I recommend taking these steps if you want to build a wetland that will last forever. Avoid building a dam, berm, or dike that's higher than the natural rim of the wetland that was drained. Avoid using a water control structure, drain pipe, or overflow pipe. Just say no to using pipes. Choose a site with a small watershed. Act to control all head cuts and erosion in the drainages entering and leaving the wetland you want to build. Use one of the techniques I've described that have proven successful for holding water. Build a wide spillway that carries water over a gradual slope that will not erode. Please watch the videos I've produced to learn more about building wetlands that will last forever. I'm not sure why anyone would build a wetland with a dam and a water control structure when they know it's going to require maintenance in a few years. This would be like buying a home that doesn't have a foundation. There's bound to be problems before you know it. Well, if you like this video, please let us know, and please hit the subscribe button so you won't miss any future episodes. And I wish you every success building wetlands in your community.
All right. Okay, let's see, we'll come back, stop share, we'll come back to the meeting room. And Tom, if you can hear us, you can unmute and turn your camera on. I think I'm gonna do that. Whoops, yeah, there we go. All right, can you hear us, Tom?
I can.
Okay, so where are we? That's you. So here's our friends. One thing about this camera is I can't get it to go up there for whatever reason. We are here, so don't, whatever, be careful if you're gonna pick your nose or whatever. So you are streaming, you just can't see it. So we're gonna pin Tom. We're gonna pin you. There we go. And we'll spotlight you here. And that should work. Okay, excellent. So we'll take questions from the room first for Tom. So thank you very much, Tom. It's a great video. It's kind of hard to keep track of just how many wetlands you were working on, but it was a really nice survey across a bunch of different types. So in the room, questions for Tom.
I just had a question about how you originally started, because I know you or Dr. Kaplan mentioned that you worked for the Forestry Service. So did you start building wetlands when you worked there, or was it later on in your career?
Thanks. That's a good question. I started off as a wildlife biologist for the Forest Service on the Superior National Forest, and this was in northeastern Minnesota. And I was reviewing timber sales, planned timber sales, and we had opportunities to change the elevation of culverts in roads we were building. And so I started out by raising the elevation of culverts, maybe 6 inches to a foot, and then we would build a small wetland. And then when you're going out to check in the timber sale, you'd see moose and beaver in the wetland. And I thought, this is pretty cool. I want to do more of this. And I started finding out, I remembered growing up in Minnesota where they were draining all these wetlands with ditches. And that was taking place, before the Clean Water Act was passed in the 1970s. And there were ditches all over the place. And I thought, there must be a way to bring these wetlands back. But back then, there were no books, no guides. You really didn't know how to build a wetland. What people were doing is building these high dams and putting in pumps. And then they would find out after 3 or 4 years, the wetland wasn't holding water and they didn't know why. So that's why I started working on these techniques so that if you were to build a wetland, you'd be successful the first time instead of going through all the embarrassment I did building wetlands that didn't hold water.
Thanks, great, Tom. Other questions from the room? Also, if you're on YouTube and you're logged in, you can put a comment or a question in the chat. Or if you're on Zoom, you can either unmute or directly pop something into chat. We do have something from YouTube, which is from Finn Green, which is, what is one of the most challenging wetlands you've worked with and why? Yeah, go ahead, tell him.
I'm going to answer that question a little bit differently. Each wetland project is unique. You have to look at how did somebody drain it, and then how can you bring the water back? But what's the most challenging part is the social aspect. Many people get really disturbed when you bring out heavy equipment, and they may have all sorts of education, but when they start seeing heavy equipment move soil, they get really nervous. And also, I find out now with the way regulations are with agencies, it's very difficult to get approval to restore a wetland because you have to go through the permitting process under the Clean Water Act. And it's very challenging. I'm hearing people call ditches linear wetlands that should be protected. So I think that's one of the greatest challenges is working with agency people, showing them that we're going to restore this wetland and it's going to be much better than the drained wetland that you're looking at today. So that's one thing I'm working on now is that how do I show people that what they're looking at now is the leftover of a wetland that was drained and that the original wetland was just so much more spectacular than the drained wetland.
Thanks, Tom. We have another question from YouTube from Adrian who asks, how long do the liners and geotextiles last in the ground before they start to degrade?
Forever. The way we're building wetlands with these aquatic-safe liners, the first one I built was in 1988, and it's still in fine condition. Basically, if you take plastic and you bury it in the ground and you put water over it, it's going to last forever. I have dug up logs in wetland restoration projects that are over 10,000 years old. So I think if we bury plastic in the ground, it'll be around forever. Now, this gives us the opportunity to build a wetland where you have permeable soil, which is from sand and rock, where you don't have groundwater and you don't have clay. And it's pretty difficult to find a new place to build a wetland because you only have so much money to buy land. So the liners are, I'd say maybe 10% of the wetlands I build now, I use aquatic-safe liners. And that's because people really want a wetland and there's no clay present. But once we get that liner in the ground, it's going to be around forever, the way we protect it.
So Tom, do you differentiate between wetland restoration, creation, enhancement, reestablishment? It seems like a lot of the wetlands you build they're new, so they're
You know
in a
what?
sense, yeah.
I believe that just about every wetland somebody builds is a restoration. Only thing is that somebody did a better job draining it. So just like in your class, you're going to have A students and you're going to have students that are not A students. And the same thing comes with drainage. If you have an A student who drains a wetland, you can no longer tell it's a wetland. And so people say, oh, wetland creation doesn't work as well as restoration. Well, I disagree with that. I believe that we can create wetlands that look every bit as good and function similar to natural wetlands. Only thing is, what I've seen across North America, people have tried to drain every single wetland. I have yet to find a natural wetland that somebody hasn't tried to pull the plug on. So when you work on a wetland project, again, you're looking at a wetland that was drained by somebody who did an A-plus job, and you have to really work to find the drainage structures and to reshape the landscape so you can bring the wetland back.
All right, thanks, Tom. This is the most active YouTube has been, I think, in the history of the seminar. So we're gonna keep going. We got questions from YouTube.
Oh, good.
This is from somebody Moffat who actually helped out at the Ball State Workshop in 2022. So
Great.
was the probably met you, and they are wondering how wetlands that you've built are evaluated long term. When you think about your construction projects, how do you measure success?
Okay, I go back to the original objectives of the project. If you're working on government land, you're going to have a National Environmental Policy Act document, and that will list the objectives for doing the project. And I go back and I look at those original objectives. Were we trying to build habitat for the eastern spadefoot? Were we trying to clean runoff? Were we trying to recharge groundwater? And I look at those original objectives and say, did we meet them? Now, one thing about monitoring, everybody says you need to monitor, but there's no money for monitoring. I've built thousands of wetlands and only a handful have been monitored because there's no funding available. I mean, we're lucky to get a poor graduate student out for a month looking at one of these wetlands. So what I've been doing in the last year is I've been going back to wetlands that I built 30, 36 years ago, and I've been monitoring them to see if they are successful. And that'll be a new video coming out, is looking at these wetlands I built 36 years ago, what worked, what didn't work, and what can we learn from that so that when you decide that you're ready to build a wetland, you're going to be successful. It's hard to get money to build wetlands, and you have to be successful the first time. I mean, how many of us would want to buy a car and have it break down the first month? And that's what's happening with most wetland projects across the US. Most of them fail within 2 years of construction. And it shouldn't be that way. If we build a wetland, I'm convinced we should build it so it will last forever. And nowadays, the wetlands I'm building, I'm guaranteeing them for 500 years. You can have your money back in 500 years if it doesn't meet your objectives.
That's great. We got a couple more questions here. Let's see. Um, This is from Billy Best from class. Do you ever use floating plants like duckweed to minimize evaporation in ponds or wetlands? So try to keep more water in the system that way.
No, I don't. I build a lot of wetlands in desert regions, whether it's Arizona, New Mexico, or in the southern interior of British Columbia. And what we find is that evaporation is not the problem with maintaining water in the wetland. The problem is percolation. So if you can control or reduce water soaking into the ground, you don't have to have that much water to maintain water in your wetland. Another thing is we look at our objectives. In these arid regions, I build mini wetlands that are vernal ponds or ephemeral wetlands, and that way I don't have to hold water all year. So, no, I haven't been using plants to do that. It'd be interesting. I would think any plant in a wetland would actually increase, evaporation, transpiration.
All right, thank you. And so we'll go back to the room if there are any more in the room. Victoria.
Hi, I have a question about, so you mentioned no pipes, drainage structures, outlet control structures. How have you found that those conversations go with maybe agencies or other engineering firms that you've worked with that are more familiar with the valves and that sort of stuff?
They don't go very well because all of us were taught to build wetlands with dams, pipes, and water control structures. Ducks Unlimited is still promoting this all across North America. And when you put a pipe in a wetland, when you put in a water control structure, when you put in a dam, you are adding a weakness. You are adding a wound that is going to fester and cause the wetland to fail. Now, I've built over 1,400 dams. I am not, I am for wetland restoration and creation, not for building dams. So I teach engineers how to build wetlands, and when they see the techniques I'm using, they go, well, that makes a lot of sense. There's nothing to maintain. You know, an engineer taught me years ago, if you put a culvert in the ground, someday you're going to have to dig it up. The same thing holds true for a wetland. If you build a dam and put a pipe in it, you're going to have to maintain it. And guess what? Agencies don't maintain their wetlands. Private landowners don't maintain their wetlands. Nobody maintains it. Think about your car. Are you doing oil change? Do you keep up with that? Think of a wetland out in the woods. Nobody keeps up with it. So why would you build something like this? I once managed over 1,000 wetlands with water control structures. We did not have the personnel to maintain those structures. And people wouldn't do it because they'd get wet and muddy. So, why do this? And this is why I'm producing these videos, is to show people there is a better way. If people can build a wetland by hand that's 2,000 years old, why would we want to build a wetland that will go away in 5 years? So that's a good question. Yeah, I hold my ground with engineers now and say, why would you want to do this? Because it's a traditional practice. We don't have to go that way anymore.
Thanks, Tom. Well, we're getting close to the end here, but there's one more from a YouTube user named I Love Ya Drony Drony. I don't know if that's
Okay.
thank you for this question. It says, you've built wetlands in a lot of different kinds of places. A while back, though, I remember you saying that a rooftop was the only place you've never built a wetland. Has that happened yet?
Oh, I would like to build one on a rooftop. You know what? It hasn't happened, but I'm looking forward to it. Years ago, my supervisor of the Forest Service came in and said, Tom, it's time to change the program. You have built too many wetlands. This truly took me aback. I said, what's going on here? So I thought about that at night. Building too many wetlands, that's like saying you have too much money. You have a car that gets too many miles per gallon. It's like saying you have a partner that's too good at looking. There's no such thing. When you look at all the wetlands that have been drained and filled across North America, you can spend your whole life building wetlands and never make up for those losses. So I'm hopeful that you will embrace this and want to go out there and build wetlands. Don't worry about it being restoration or creation. Just get that habitat on the landscape. And I'm convinced it's the most important thing you can do to help the environment, plants and animals, is to bring back a wetland.
Well, that's a great place to stop. So let's thank again, Tom Biebighauser. We really appreciate you launching us off this semester. Thanks again.
Thank you very much. Appreciate it.
Tom, I'll be back in touch. I'll end the Zoom now, but thank you so much for joining us today. And I'm
Thank
gonna be in
you.
touch with you about, maybe we can go monitor some of those wetlands together. It'd be really fun. All right, thanks
Great.
everyone. So get your abstracts
you.
in. They're due Tuesday, basically a week from today. Any guidance you need, email me with questions. There's some abstract examples now listed under the discussion. From my side, if Dr. Clark, you want to share the same, and we will see you all next week. Thank you.